In this video, we're going to be learning about complex numbers. We're going to add and subtract, multiply, divide, square roots of negative numbers, solve quadratic equations with complex solutions. All right, first of all, this is important. This is a definition. A definition just is, I have had students in the past ask me, well, why is I equal the square root of -1? With definitions, there is no why. No why to definitions. It just is. Somebody said this is the way it's going to be, and everybody else has to follow along. So I is equal to the square root of -1. By the way, it is not a capital I. And it's not a lowercase I in that you got to put it with italics. That's not a backwards J. That is a lowercase I that's been italicized. And my best attempt at a lowercase I that's been italicized looks a lot like a backwards J. But it is not. It is an I. Okay. I squared, that is equal to -1. So those are things you need to know. I is equal to the square root of -1, and what did I just say? I is equal to the square root of -1, and I squared is equal to -1. Complex numbers. So if you take a real number and add an imaginary number, you end up with something called a complex number. And we usually talk about it as A plus BI. So A is the real part of the complex number, and B times I is the imaginary part of the complex number. If it doesn't have a real part, let's say, for example, you have something like 12i. Well, plus 0 to be technical. If it doesn't have a real part, we call it pure imaginary. Adding complex numbers, subtracting complex numbers, and multiplying complex numbers is basically identical to how we add, subtract, multiply binomials. So to add, we combine like terms. To subtract, we distribute the negative and combine like terms. To multiply, you could use the FOIL method. I recommend using the box method. You know me in the box method. So yeah, it's the same as using how we do it with binomials. So let's suppose we have two complex numbers. In order to add them together, we would take the real part of one and the real part of the other and add those together. And we take the imaginary part and the imaginary part and add those together. Very straightforward. Okay. To subtract, you distribute the negative. All right, let's do a couple examples. So with this one, we have a real part of 5 and 3. We add those together. We have an imaginary part of -2 and 3i. We add those together, and we get 1i. And done. The next one, what we're going to do, because it's subtract, we're going to distribute the negative and then combine like terms. So the 2 and the -12, and the 6i and the I. To multiply, in this case, we would distribute. So we would multiply 7i times 2 and 7i times 9i. Now with this one, we're going to get our -63, and we're going to multiply I times I. That gives me I squared. Earlier, I mentioned that I squared is -1. Whenever you get an I squared in your answer, you have to replace it with -1. Don't forget to do that. So you have 14I minus 63 times -1. And that gives me 14I plus 63. We always put the real part first and the imaginary part second. And we know it's imaginary because it has I. So that's the imaginary part that has to come second. Okay, with this one, like I said earlier, you could use the FOIL method, but again, I don't recommend FOIL method to anybody. You can use it if you want, but the box method is the same. It's just more visual. So you're still going to end up multiplying the 6 times the 5 and the 6 times the 4i, 5 times -7i, and -7i times 4i. Don't forget, and you're going to combine like terms. So you have 30, you're going to combine the i's. So if I add those together, I have -11i. And then I squared, don't forget you have to replace that with -1. So 30 minus 11i plus 28. I'm going to combine that with the 30. Okay, there is something called a complex conjugate. Complex conjugate is where the first number is the same, the second number, the imaginary number, is the same, but they have opposite signs. So we have a plus bi, a minus bi, and when we multiply them together, because it's a difference of squares, the two middle terms will end up canceling each other out. So we have a positive ABI and a negative ABI. Those will cancel each other out. And in the bottom right-hand corner, we would have negative BI squared, but the I squared we replace with -1. So right now we have A squared minus B squared times -1, which gives us A squared plus B squared. Multiplying conjugates gets rid of the I. Dividing by a complex number, it looks nothing like division, to be perfectly honest. What it looks like is rationalizing the denominator. If you remember from radicals, when we were doing radicals, we had to rationalize the denominator by multiplying by the conjugate. Well, same thing here. So we call it division, but it's not going to look like division. What it's going to look like is rationalizing the denominator. So what does that mean? We are going to find the conjugate of the denominator. So the first number is the same, and we have the I, but instead of minus, we would change that to a plus. So they have to have opposite signs. What you do to the bottom, you have to do to the top as well. So we're going to multiply 5 plus 4i and 4 plus I. So we multiply the 4 times the 5 and get 20. 4 times 4i is 16i. 5 times I, and then 4i times I is 4i squared. But again, don't forget you have to replace your I squared with -1. So right now in the numerator, I've got my 20. I'm going to add my 16i and my 5i. And I'm going to replace my I squared with -1. That's in the numerator. In the denominator, you can either use FOIL to multiply, or you can use a box, or you can use the formula that was on the last slide. So these will cancel out, as you may remember. So we end up with the first 1 squared plus 1 squared. So where did we get that? So we have our 16 minus a -1 is 16 plus 1, which is the same as if you were to use the formula. So 16 plus 1 is 17. And we are going to combine like terms. So this gives me -4. So I have 16 plus 21i over 17. This is never how we write the answer. What we do is we separate the fractions by putting the denominator under both of these. So put 17 under the 16 and put 17 under the 21, and then put your I. Simplify these fractions if possible, but that's not possible so in this example. So that would be our final answer. Simplifying square roots of negative numbers. Okay, simplifying square roots of negative numbers. Let's suppose we have the square root of -25. You can rewrite that as the square root of -1 times 25. One of the things we can do with square roots, if it's multiplication, we can separate them. The square root of -1 is defined to be I, and the square root of 25 is 5. We do put the 5 in front of the I. So the square root of -25 is 5i. And that's basically what they're saying right there. Okay, so what they want us to do is add these two radicals together. Well, in order to add radicals, they have to be like terms, and they currently are not. You also have to, these can be simplified, and right now they're not simplified. So we have -1, and 27 is 3 times 3 times 3. 48. I don't remember 48. So, oops, 6 times 8, 2 times 3. Okay, so we have 4 twos. 1, 2, 3, 4 twos, and a 3. Okay, I shouldn't have done the parentheses, whatever. Okay, so when we're simplifying square roots, 2 of the same thing will come outside of the radical, and square root of -1 comes out as an I. So the square root of -1, that's going to be an I. The square root of 9 is 3, and I still have this 3 left over inside the radical. So this one gives me an I. I've got a couple 2's, so this is the square root of 4 and the square root of 4. So 2 times 2 is 4, and then I still have my square root of 3. Okay, to be able to combine these, since one of them has an I, the other one has to have an I. Since this has a square root of 3, this one has to have a square root of 3. They have to be like terms, which they are. So we can add the 3 and the 4. And get 7i square root of 3. All right, what else? All right, let's take a look at this one. We are squaring this, so I want to caution you against trying to do this in your head. A lot of students mess it up when they try to square it because they forget these two terms. They just square the 2 and square the square root. Okay, so we're going to take and before we start, what we want to do is take care of that negative. So I'm going to actually redraw my box. Try again. Okay. So because this is square root of a negative, I'm going to take the I out for both of them. Now, taking this I does not change that one. So just to be aware. So that will give me 4, 2i square root of 3, 2i square root of 3. And then a negative times a negative is positive. I'm going to multiply the i's together, and then the square root of 3 has to be squared as well. So when I combine like terms, I have this 4, and then I have 4i, so I've got 2 of those. 4i square root of 3. And then for this one, I squared is negative 1. I'm going to put a negative there. If I square a square root, the square and the square root cancel each other out. So I'm left with 3, negative 3 because of the I squared. So I'm going to combine the 4 and the negative 3. And that would be the final answer. Okay, this is the one that we were supposed to be working on. Okay, so if we have x squared minus 2x plus 2 is equal to 0, they told us to solve using the quadratic formula, so we need a, b, and c. So x is equal to negative b plus or minus b squared minus 4 times a times c all over 2a. And we're going to simplify this starting on the inside and working our way out. Plus or minus, so negative 2 times negative 2 is 4. Negative 4 times 1 times 2 is negative 8. Four minus 8 is negative 4. Two plus or minus, the square root of negative 4 would be 2i. We take the square root of the negative and the square root of the 4 over 2, and I can factor out the 2 from the numerator. And I can cancel. And time for the learning reflection.